Dear students, in last class we have discussed about the chapter matrix. In today's class we have discussed about construction of a matrix. Yesterday class we have already discussed about two problems. In today's class one more problem we will discuss, that is construct a 2 cross 2 matrix whose elements are given by Aij is equal to I plus j whole square dividing by 2. Solution: in general, a 2 cross 2 matrix is given by A equal to matrix A is A11, A12, A21, A22. It's a 2 cross 2 matrix. Here A11 is the first row first element, A12 first row second element, A21 second row first element, A22 second row second element, second row second element. So now Aij is an element, that is I plus j whole square dividing by 2, where I is equal to 1 comma 2 and j equal to 1 comma 2. So first find A11. I is 1, j is 1, so A11, I plus j, I is 1, j is also 1, 1 plus 1 whole square by 2, 1 plus 1 2 whole square becomes 4 by 2 is equal to 2 ones are 2 twos are. Therefore A11 becomes 2. A second element A12, I is 1, j is 2 whole square dividing by 2 is equal to 1 plus 2 3 whole square 9 by 2. Second element 9 by 2. The next find A21. I is 2, j is 1, 2 plus 1 whole square dividing by 2, again 2 plus 1 3 whole square 9 by 2. A last element A22. I is 2, j is also 2 whole square by 2 is equal to 2 plus 2 4, 4 square 16 by 2 is equal to 8. 2 8s are 16. So hence the required matrix A is equal to, substitute these elements in general matrix. A11 2, A11 is 2, A12 9 by 2, A21 also 9 by 2, A22 also, that is 8. It's a required 2 cross 2 matrix. Now one more example, construct a 3 cross 4 matrix whose elements are given by Aij is equal to 2i minus j. It's an element 2i minus j. Construct 3 cross 4, 3 rows and 4 columns. In general, a matrix. Solution: in general, a matrix 3 cross 4 is given by A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34. So 3 cross 4, 3 rows and 4 columns. So now by using this element Aij is equal to 2i minus j, I is equal to 1, 2, 3 and j j is equal to 1, 2, 3 and 4. So now first find a11. A11 2, I is 1. 2 into 1 minus j also 1 is equal to 2 minus 1 is equal to 1. First element becomes 1. The next point a12. a12 is equal to, so 2 into 1 minus 2 is equal to 2 minus 2 is equal to 0. The next find a13 is equal to 2 into 1 minus 3 is equal to 2 minus 3 is equal to minus 1. The next a14 is equal to 2 into 1 minus 4. 2 minus 4 is equal to minus 2. The next find a21 is equal to 2 into 2 minus 1 is equal to 4 minus 1 is equal to 3. a22 is equal to 2 into 2 minus 2 is equal to 2 2s are 4 minus 2 is equal to 2. a23 is equal to 2 into 2 minus 3 is equal to 4 minus 3 is equal to 1. a24 2 into 2 minus 4. 4 minus 4 is equal to 0. The next find a31. a31 is equal to 2 into 3 minus 1 is equal to 6 minus 1 is equal to 5. a32 is equal to 2 into 3 minus 2. 6 minus 2 is equal to 4. a33 is equal to 2 into 3 minus 3 is equal to 6 minus 3 is equal to 3. a34 is equal to 2 minus 2 into 3 minus 4. 6 minus 4 is equal to 2. So therefore, or finally, the required matrix is A is equal to A11 is 1, A12 is 0, A13 minus 1, A14 minus 2, A21 is 3, A22 is 2, A23 is 1, A24 is 0, A31 is 5, A32 is 4, A333, A34 2 is a 3 cross 4 matrix. The next concept is types of matrices. Types of matrices. Types of matrices. What are the types of matrices? So one is zero matrix or null matrix. Null matrix. Second one, row matrix. Third one, column matrix. Column matrix. So fourth one, square matrix. Square matrix. So fifth one, diagonal matrix. Diagonal matrix. Sixth one, scalar matrix. Seventh one, identity matrix. Identity matrix or unit matrix So these are all types of matrices. So zero matrix or null matrix, row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, identity matrix or unit matrix. Now, first one, zero matrix or null matrix. What is a zero matrix or null matrix? A matrix in which all elements are zeros, or a zero matrix is said to be a matrix if all its elements are zeros. For example, 0, 0, 0, 0 is a zero matrix of order 2 cross 2. The zero matrix is denoted by 0. 0 equal to 0, 0, 0, 0 is a 2 cross 2 0 matrix. Or 0 is equal to only 0 is 1 cross 1 matrix. Or 0 is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0, say 3 cross 3 matrix. The order of zero matrix is 0 m cross n, m into n, the zero matrix. Now second one, row matrix. Row matrix. A matrix having only one row is called a row matrix. For example, matrix A is equal to 1, 2. What is the order of this matrix? 1 cross n. The order of row matrix is 1 cross n. Similarly, one more example, matrix B, 1, minus 2, 0. Order of this matrix 1 cross n. It's a row matrix. Third one, column matrix. Column matrix. A matrix having only one column is called a column matrix. For example, A, matrix A is 7, 0, minus 1. Order of this matrix is m cross 1. One more example, matrix B is equal to, so 0, minus 1, 8, minus 2. So order of this matrix m cross 1. A matrix having only one column is called a column matrix. The next one, square matrix, fourth one, square matrix. A matrix in which the number of rows is equal to the number of columns is called a square matrix. number of rows is equal to number of columns. For example, matrix A is equal to 1, 2, 3, 4. What is the order of this matrix? 2 cross 2. So number of rows 2, number of columns also 2. Okay? Equal number of rows equal to number of columns. A matrix in which number of rows is equal to number of columns is called a square matrix. So matrix B is equal to 1, 3, 7, 4 minus 1, 0, 9, 8, 5 is also a square matrix. So order is 3 cross 3. In a square matrix, the diagonal that runs from left top corner to right bottom is called a principal diagonal elements or leading diagonal elements. In matrix A, the elements 1 and 4 are principal diagonal elements, left top corner to right bottom. These elements are called principal diagonal elements. Other elements, rest of the elements are called non-diagonal elements. Here principal diagonal element is 1 and 4. In matrix B, the principal diagonal elements are 1 minus 1, 5. Left top corner to right bottom of the elements are called principal diagonal elements or leading diagonal elements. In a square matrix, the diagonal on the principal elements, the elements on the principal diagonal is called the principal diagonal element. One more example, matrix C is equal to 0, minus 1, 3, 4, 5, 7, minus 1, 7, minus 3. In square matrix C, the principal diagonal elements are called 0, minus 0, 5, minus 3, 0, 5, minus 3 or principal diagonal elements. The next one type, diagonal matrix. Diagonal matrix. What is a diagonal matrix? You know that square matrix, number of rows equal to number of columns. A diagonal matrix is a square matrix, or a square matrix is said to be a diagonal matrix if all its elements are zeros. All its elements are zeros means non, or if all its principal diagonal elements of all non-diagonal elements. That is, for example, matrix A is equal to 1, 0, 0, 0, 2, minus 0, 2, 0, 0, 0, 3. Say example of diagonal matrix. A square matrix. This is one square matrix. A square matrix is said to be a diagonal matrix if all its non-diagonal elements are zeros. Non-diagonal elements is here. So 0, 0, 0, 0. So these 1, 2, 3 that is called principal diagonal elements. If all its non-diagonal principal non-diagonal elements are zeros. One more example, v is equal to, so 1 0 0 2, non-diagonal elements are zeros. 2 cross 2 matrix. The next one, sixth one, scalar matrix. A diagonal matrix is said to be a scalar matrix if all its diagonal elements are equal. Example, matrix A is 2 0 0 0 2 0 0 0 2, means they are also a diagonal matrix. Here principal diagonal elements are equal, so 3 cross 3 matrix. Matrix B is equal to, so minus 2 0 0 minus 2, principal diagonal elements are same or equal. The next one more, identity matrix. Identity matrix or unit matrix. What is identity matrix? A square matrix in which elements in the diagonal are all 1 and are all rest zeros That means, example, matrix A is equal to 1 0 0 0 1 0 0 0 1. Order is 3 cross 3. So identity matrix is a diagonal matrix in which principal diagonal elements are unity. Principal diagonal elements are unity. Okay. Here, observe that a scalar matrix is a identity matrix. Scalar matrix is a identity matrix when principal diagonal elements are unity. Principal diagonal elements are unity means 1. These are all principal diagonal elements, 1 1 1. Okay, but every identity matrix is clearly a scalar matrix. The identity matrix or unit matrix is denoted by I, that is capital I. That is only I, not A, B, C. So I. One more identity matrix is 1 0 0 1, say 2 cross 2 matrix. Clearly? Okay, so these are all types of matrices. Again, zero matrix, row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, identity matrix. Again, zero matrix, a matrix in which every element is a 0 is called a zero matrix. Second one, row matrix, a matrix in which having only one column, this is a row matrix, sorry, a matrix in which having only one row is called a row matrix. Column matrix, a matrix in which only one column is called a column matrix. Square matrix, a matrix in which the number of rows is equal to number of columns is called a square matrix. The next, diagonal matrix. A square matrix is said to be a diagonal matrix if all its non-diagonal elements are 0. Scalar matrix. A scalar matrix is said to be a diagonal matrix if its elements are equal, if its diagonal elements are equal. Identity matrix. A square matrix in which elements in the diagonal are 1 and rest are all zeros. So, identity matrix. The next concept is equality of matrices. Equality of matrices. Equality of matrices. Two matrices are said to be equal if they are of the same order. The two matrices order, same, they are of the same order. Second point, element of matrix A is equal to the corresponding elements of matrix B. So these 2 points is very important. They are of the same order. Every element of matrix A is equal to the corresponding elements of matrix B. Okay. For example, matrix 2, 3, 0, 1, order 2 cross 2, and one more matrix 2, 3, 0, 1 are equal matrices, because so also order is 2 cross 2. Both of matrices orders are same, 2 cross 2, 2 cross 2. They are of the same order, and each element of matrix A is equal to the corresponding elements of matrix B. So the element of matrix A is 2, corresponding element of matrix B 2, element of matrix A is 3, corresponding element of matrix B also 3, 0, 0, 1, 1. So therefore these two matrices are equal matrices, but matrix A 3, 2, 0, 1 and matrix B 2, 3, 0, 1 are not equal matrices, because so corresponding element of matrix A3 is not equal to 3, here 2, here the corresponding element of matrix is 2, here 3. So therefore these two matrices are not equal matrices. Okay. Here one more example of equal matrices. Here one example here, matrix 4, 3, x 5 is equal to y, z, 1, 5. These two matrices are equal matrices. Find the values of x, y and z. The corresponding element of 4 is y. So therefore y is equal to 4. The corresponding element of 3 is z. The value of z is 3, and the corresponding element of x is 1. Therefore x is equal to 1. So therefore x value 1, y is 4 and z is equal to 3. Find the value of x, y, z. Okay, right. So one more example, find the values of x, y and z in the following matrices. So matrix x plus y plus z, x plus z third element y plus z is equal to matrix right hand side 9 5 7 9 5 7. These two matrices are equal matrices. Order is 3 cross 1. So also order is 3 cross 1. Then find the value of x, y, z. Here is the corresponding element of x plus y plus z. X plus y plus z is equal to 9. X plus z is equal to 5. Y plus z is equal to 7. Y plus z equal to 7. So substitute in this equation. So x plus y plus z equal to 9. Therefore x plus y plus z is 7 is equal to 9. X is equal to 9 minus 7. X is equal to 2. The value of x is 2. Substitute x, the value of x is 2 in second equation. X plus z is equal to 5. So x is 2. 2 plus z is equal to 5. Therefore z is equal to 5 minus 2. Z is equal to 3. You know value of x is 2, z is 3, and y, the last equation, y plus z is equal to 7. Y as it is, z is 3 is equal to 7. Therefore y is equal to 7 minus 3. Therefore y is equal to 4. The value of x is 2, y is 4, and z is equal to 3. Okay, right. Find the values of x and y from the following equations. Equation 1, matrix x plus y 2 5 plus z xy equals matrix 6 2 5 8. Second one, 3x plus 7 5 y plus 1 2 minus 3x equal to 0 y minus 2 8 4. Second problem, find the value of a, b, find the values of a, b, c and d from the equations. A minus b, 2a plus c, 2a minus b, 3c plus d equals minus 1, 5, 0, 13. Take these two problems, no mark. Okay. Stop it here. So we'll continue in the next class. Okay, thank you.